Hello, I'm Zhang from South China University of Technology. And first, I want to thank the committee for hosting us today. Today, on behalf of Professor Yimin Sun, I would like to share with you the design and construction of Wuhan University Gymnasium, which is finished by our studio. Okay, let's start with the background introduction of the project. Since the cooperation in 2000, Wuhan University is developed rapidly and put forward large demands for the support career. However, the campus facilities were insufficient and mostly unable to meet the requirement of today's sports activities. Therefore, the university decided to build a student sports center, which was positioned as a grade A sports venue. The construction site is close to the west gate of the campus, which is basically in the north to south direction. The gymnasium has an area about 37,000 square meters, include about 10,000 square meters on the ground. We faced some challenges in the project. First, external environment. The palace-style early buildings form a unique atmosphere of the campus, strongly affecting the form design of the gymnasium. There is a height difference is about 4 meters within the site, which brings certain difficulty to the construction. For the internal function, as a large college gymnasium, it is required to meet a variety of functional demands at different periods, and meanwhile, to support certain professional events. Here are some photos of the campus. We can see the university logo has an image of the palace-style building. To solve the above problems, first we carry out environmental integration. We design a large platform by making use of terrain height difference to separate the evacuation and parking issues. In the staggered roof to form a building image that can integrate to the campus. This roof also creates a good conditions for nature lighting and ventilation. Second, we focus on the functional flexibility. For example, a size of 22 meter times 42 meter is set as a multi-purpose field, which can arrange various activities. The retractable and temporary seating can increase the flexibility of the space. The surrounding rooms for teachers and students can be converted according to different requirements. In here, the function flexibility is about our design. Here are some photos of the opening ceremony and the general meeting. You can see the retractable seatings and the flexible use of the space. The third is technical rationality. Appropriate technologies adopted with the consideration to two types of patterns, named the daily activities and the professional events. To this end, BIM, intelligent equipment system, advanced computer tools such as ArchiCAD, Ecotech, and Fluent are used in the project. For the structure, after optimization, a large span X-shaped three-dimensional string structure is used for the roof support system, which can transmit force through the common node. The comparison among the different structure programs shows that the one chosen for full project is concise, lightweight, and can reduce the amount of steel used to the larger extent. Here are the photos of the roof, from which we can see the X-shaped structure elements. The key principle of active house is the balance about comfort, energy, and the environment. The research is about multidisciplinary and multi-objective design, exploration, and optimization. It provides an effective early decision support for the conceptual design of the project. The early design decisions can affect not only aesthetics of buildings, but also series of technology, performance, and sustainable operation. Therefore, the research aims to propose a method that can optimize the daylight performance of the project while integrating other multidisciplinary performance objectives. In the early design phase of the project, parameters defining the roof geometry and the fenestration systems were considered as variables, and the other performance criteria were used to formulate objective function and constraints. We could also find optimize the roof from the consideration to the daylight and other quantitative performance, which provide a favorable support in the conceptual design for the designers. And eventually, two-step staggered roof with daylight is adopted for the improving the natural lighting in the large stage. For the light environment, the main space of the gymnasium is illuminated by the means of the skylight belt on the ridge and the highest side lighting strip. The combined area of the two is about 1,000 square meter, with about 15% of the roof. Here are the section of the skyline belt on the lighting strip. Can be seen. The simulation results show that the project is very good condition for natural lighting without being shaded by the surrounding buildings, and the area of the daylight factor larger than 2% is shown on the right. almost cover the whole area of the main hall and the deputy hall. Here are the real photos, main hall and the deputy hall, from which it can be seen that indoor light environment of both halls is satisfactory. For the thermal environment, I have mentioned earlier, the roof creates a good condition for natural lighting and ventilation. The height of the building is about 29 meters, which forms a significant temperature gradient, and this is used in our design to create heat pressure ventilation when the device off. Simulation results by Fluent show that the significant airflow is formed in the auditorium and the competition area, with wind speed mostly is at 0.5 to 1.5, which can improve the indoor thermal comfort in transitional seasons. When the device is on, the system is designed to ensure the indoor thermal environment to be within the certain comfort zone. For example, the auditorium is at 24 to 27 degrees Celsius, and the wind speed at 0.1 to 0.8. These are similar in the competition area. About the maximum wind speed is controlled to avoid the impact of excessive wind on the sports activities. And we also optimize the flow organization of the air supply to ensure the airflow can evenly cover the entire indoor space. The project has been completed and put in use since September this year, becoming the largest university gymnasium in China. It has been widely reported by many media. From this, it can be seen that the peers, media, and owners affirm the design strategies of respecting the campus environment, following the functional rationality, and applying suitable technologies. In our plan, we want to carry out POE on the project finished by our studio, and the first groups of the research project are aimed at 13 venues, including the Wuhan University Gymnasium. So we would see what's going on with the project in the coming years. The project has won several awards, such as the Green Construction, the Green Demonstration Project, the Beam Competition Award, and so on. And today, on the behalf of our studio, I feel honored to share our design and research here. Thank you very much.